In this video, we're going to practice simplifying or simplifying algebraic expressions together. And for these particular practice problems, we're only going to be dealing with expressions that have addition, so we're not going to be dealing with anything that has any minus signs or subtraction. For number 1, we have the expression x plus x plus x plus x. Now because there are 3 plus signs, we have 4 terms here, so we have x plus x plus x plus x, and all these terms happen to be like terms with each other because they all have that variable x. Now technically all of these x's have a coefficient, so I'm going to go ahead and write that out. Now because these are all like terms with each other, all we really have to do is go ahead and add these coefficients. So 1 plus 1 plus 1 plus 1 means that we're going to have a total of 4 of these x's. So this expression, when we simplify it, is just going to be 4x. We can't simplify it anymore. Now again, each of these terms of 1x plus 1x plus 1x plus 1x are all like terms with each other because they all have an x, so they can be combined together. For number 2, we have this expression of y plus y plus y plus y plus y. So there are 5 of them. So let's go ahead and rewrite these, but we're going to show their coefficients as well here. So each of them are going to have a 1 in front of them like this. Alrighty, so now we see their coefficients are all 1. So we have 1y plus 1y plus 1y plus 1y plus 1y. And we can go ahead and add all their coefficients together because they all have a y. So 5 of those 1's added together is going to get you 5 of these y's, or 5y for our simplified expression. For number 3, we have a little shorter expression. This time we have 3x plus 7x. Now these both have the same terms as well here, so 3x and 7x are like terms with each other. If we go ahead and rewrite this showing their coefficients a little bit more clearly, we have 3 of these x's over here, and they're going to be adding on 7 more of these x's. And because they're like terms, we can go ahead and add their coefficients. So 3 plus 7, that's going to equal a total of 10. So if we simplify this is going to be 10x for our most simplified expression. For number 4, we have this expression of 6y plus 2y. These are like terms with each other. If we want to see what we're going to be combining, this is going to be the coefficient of 6 of these y's. And then we're going to go ahead and add on 2 of these y's. So we're going to go ahead and take a look at those coefficients, right? Now they both have like terms because they have y. Now 6 plus 2, that's going to equal 8. So simplifying this, we have 8y for our expression. Let's take a look at number 5. So for number 5, we have a few terms here that all have x in common for the variable part. So we have 3x plus 5x plus 7x. Let's go ahead and see what we're combining here. So we're going to have 3 of these x's. That's a coefficient of 3. Plus we have 5 more of these x's. So these can be combined. Plus we have 7 more of these x's. Alrighty, so they all have x, which means they are like terms with each other. So all 3 can be combined with each other. 3 plus 5 is 8, and then 8 plus 7 is going to be 15. So adding all the coefficients together, we get 15 of these x's, or 15x. For number 6, we have another similar problem here. Notice about variable terms. We have 7y plus 4y plus 10y. They all have y's. So let's see, if we are trying to make these coefficients a little more clear, we have 7 of these y's, plus we have 4 more of these y's, plus we have 10 more of these y's. Now these are like terms with each other because they all have just a regular y attached to them. So adding their coefficients, 7 plus 4 is 11. 11 plus 10 is going to be 21. So most simplified, this is going to be 21y for our expression. Moving on to number 7, this one's going to be the first time it's going to be a little different here. Now this 2x and 5x are going to be like terms with each other because they both have that x value. And then this 8 and this 3, these constant terms, are also going to be like terms with each other. So writing those, making their coefficients a little more clear, we have 2x plus we have 5x. So you can change the order if you're adding everything, that's perfectly fine. So we have this 8 for a constant plus a 3 for a constant, right? Now keep in mind, what are we able to combine here? This 2x and 5x, if you add the 2 plus 5, that's going to be 7. So it's going to be 7x when you combine those. And then we can also combine our other constant terms of 8 and 3. So 8 plus 3, that's going to be a total of 11. So 7x plus 11 is going to be our most simplified expression. For number 8, we have 7y plus 4 plus 8 plus 2y. So we have 7y and 2y. These are going to be like terms with each other because they both have y. And then this 4 and 8 are constant terms, so they're going to be like each other. Okay. Now this 7y, I'm just going ahead and write like this, 7y, so you can see the coefficient very clearly. Plus the 2y, I'm going to put a 2 and then a y right over here. And then what else do we have? We have two constant terms here. So we're going to have our 8 and our 4. So we're going to have 4 and I'm going to have our plus our 8 as well. Forgot to make a plus sign in this color earlier. I'm just going to do that before it bothers me too much. All right, so what can we combine here? Well, we already identified hopefully this 7y and 2y. We can combine those coefficients. 7 plus 2 is 9. So those combine to make 7y. Plus, what else do we have here? Looks like we have our constants of 4 plus 8. 4 plus 8, last time I checked, is 12. So we're going to put a positive 12 here, and this would be our most simplified expression. Here is number 9. For number 9, we have the expression 3x plus 2 plus 6x plus 8. This 3x and 6x are going to be like terms, and then this 2 and 8 are constant terms, and they're going to be like each other as well. Now, instead of writing 3x using just black, I'm going to make the coefficient pop a little bit more. So we have 3x plus, and we have the 6x. We're going to put 6x over here, and then we're going to add our constants. So we have 2, and then we also have an 8. Okay, so let's go ahead and combine our 3x and 6x. They're like terms with each other. If we combine those, that's going to be a total of 9x. So we're going to have 9x. Now 2 plus 8 is going to be 10, so we're going to put a 10 over here, and that would be our final expression. This can't be simplified anymore. Okay, let's take a look at number 10, where we have y plus 5 plus 3y plus y plus 4. Let's see what we got here. So this 1y rather, and this 3y and this 1y are all like terms with each other. I'm going to go ahead and rewrite those. So this is a 1y, keep in mind that has an invisible coefficient, a little tricky, plus this 3y, and then plus we have one more y. So I'm going to put that 1y here. All right. Now what else are like terms here? Well, we have this constant of 5 and a 4. So let's go ahead and just add this 5 and 4 at the end here. So we have a normal 5 and a normal 4. Those are our constant terms. All right, let's combine these first like terms. So 1y plus 3y plus 1y, add those coefficients. 1 plus 3 plus 1 is going to be 5. So our coefficient is going to be 5, and then we have this y at the end here. Then combining our constant terms of 5 plus 4, combining those is going to get you 9. So we're going to have 5y plus 9 as our final expression. All right, number 11, we have 3x plus 5 plus 7x plus 9. Let's see what our like terms are here. So it looks like 3x and 7x are going to be like terms. Let's go ahead and just rewrite those real quick. So we have 3 of these x's. We're also going to combine that with 7 more of these x's. We have 7x. And then let's see, we have some constants here, right? So our constant terms are going to be 5 and a 9. So let's go ahead and add those together here. So we are adding on a 5 as well as a 9. Okay, so let's go ahead and just combine our like terms of 3x and 7x. We can add those coefficients. So 3 plus 7 is 10, so we have 10x when we combine those. Plus, when we go ahead and combine our constants of 5 and 9, 5 plus 9 is going to be 14, so that combined constant is going to be 14, and that's as far as we can go. For number 12, we have this expression of 3y plus 4 plus 8y plus y. Our like terms here with the y's are going to be 3y, 8y, and this 1y. Let's go ahead and just write that real quick. So we have 3 of these y's, and then we're going to add on 8 more of these y's. And then finally, we're going to add on 1y at the end here. In addition to all that, we seem to have one constant of 4. Now that one is just going to be hanging out by itself. It doesn't have any like terms, so we're just going to write that by itself there. And if we go ahead and combine our like terms of 3y plus 8y plus 1y, you can add those coefficients. 3 plus 8 is 11, 11 plus 1 is 12. So we're going to get a total of 12y here. And then we're going to add 4 on at the end, right? So this is going to be our final expression. Couldn't really do anything with this 4, so we're just going to leave it by itself. Here's number 13. For number 13, we have 8 plus 3 plus 5y plus y plus 2. I'm going to start with the terms that have the y. So we have this 5y and 1y. They're going to be like terms with each other. So rewriting this, we're going to take this 5 of these y's, and we're going to combine it with 1 more of these y's. So I'm going to put a 1y over here. And then after that, it looks like we have a bunch of constants here, right? So we have some regular old constant values of 8, 3, and 2, or just regular old numbers here. So let's go ahead and add this 8 at the end here, plus this 3. And then let's go ahead and add this 2 at the end as well. Alrighty, so it's a little bit more clear, hopefully, what we're doing. So this 5y plus 1y, we can combine those coefficients. 5 plus 1 is 6. So we're going to get 6y when we combine them. And then at the end here, let's go ahead and combine this 8 plus 3 plus 2. 8 plus 3 is 11. 11 plus 2 is 13. So we're going to add on a constant at the end here of 13. For number 14, we have 3x plus 8 plus 6x plus 4. Notice this 3x and 6x, they're going to be like terms with each other. We also have this 8 and 4, which are constant terms, but let's take a look at the x terms first. We have 3 of these x's, and then we're going to go ahead and add on 6 more of these x's, so we're going to add on 6x here. Then afterwards, we have a constant of 8, as well as a constant of 4. All right, so let's go ahead and start combining some like terms here. So 3x and 6x, adding those coefficients together, that's going to be a total of 9x. And then if we go ahead and add these constants at the end here, we have this 8 plus 4, that's going to be a combined value of 12. So we have 9x plus 12, and that'll be our most simplified expression. All right, last two here are 15 and 16. For 15, we have y plus 4y plus 3 plus 5y. So let's take a look at the y terms first. We have 1y, 4y, and 5y. So let's go ahead and write this a little bit more clearly. We have 1 of these y's, plus we're going to have 4 more of these y's. And then finally, we're going to add on 5 of these y's. And then we have a constant term here, but it's kind of on its own. So this 3 here is just kind of be hanging out. And so we're just going to put a plus 3 at the end. It's not going to be combined with anything though. Okay. Let's combine this 1y, 4y, and 5y. So 1 plus 4 is 5, 5 plus 5 is 10. So we have a final coefficient that's combined of this 10y. And then we have a constant of 3 at the end here. So this 3 kind of just got left on its own. It's a constant, and there were no other constants. So we just leave that alone. Finally, for number 16, we have 5x plus 3 plus x plus 8x plus 1. Our like terms here that have x's are going to be 5x, this 1x, and this 8x. Let's go ahead and write that out. So we have 5 of these x's, but we're going to be able to combine that with 1 more x. That's that just plain old x you see there. Then we have 8 x's, so we're going to add 8x at the end here. And then we do have some constants that we can combine here. So notice that we have this 3 and this 1. And so if we go ahead and add those at the end here, we can add a plus 3 and then add a plus 1. Okay, so those are our constants. If we go ahead and start combining things here, 5x plus 1x is 6x. 6x plus 8x is going to be a total of 14x. So combining those, we have 14 and then x. And then plus, we can go ahead and combine our constants here of 3 and 1. 3 plus 1 is going to equal 4. So 14x plus 4 is going to be our final expression. Alrighty, so there you have 16 different practice problems where we practiced combining like terms, and all of these had plus signs, so we didn't have to worry about any negatives or subtracting anything, and so we'll save that for another video. So if you found this video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.